Welcome back, everyone. So in this video, we're going to look at polynomials, but we're going to focus on the calculator tricks and calculator mechanics of this. So we're given a function. So this left-hand column, we're going to be given a function in polynomial form. And then over here on the right side, we're given a function that's going to be in factored form. So all of these questions are going to be calculator-based, so it's really going to be testing your knowledge on how well you know how to use your calculator. So starting off, I'm going to reset my calculator. So menu, I'm going to go down to System, then F5, F2, F1. Ta-da. All right, now I want to be able to graph this function and be able to look at the attributes. So I'm going to go to my graph function, and then I'm going to type in my function. So 6.4x raised to the third power. Then I want to toggle out of the exponent, then minus 11x squared plus 0.05x. Now be careful when you're reading because I made this mistake several times. This is 0.05x, not 0.5x. So I made that mistake I don't know how many times, and of course this is take who knows how many videos I've tried to record this because I keep messing up. Oops. So now that I plugged it in, press draw. And this is going to be your standard view of your graph. So I need to adjust it. So as a little reminder, on the Casios, you can toggle on the cursor pad up and down as needed. And then you can also press the plus or minus sign to zoom in and zoom out respectively. So zoom in. So I'm still going to adjust these values on my window manually. So to adjust the values manually, I'm going to press F3. So my X values are actually kind of far out. So I'm actually going to kind of squeeze it in a little bit more. So I'm going to go to -3 to +3. And then my Y values, I'm going to go to, let's do -8 to +8. Let's see how this goes. That's a pretty good view. I'm going to scooch over a bit. All right, so now that I have a really good view of my graph, now I'm going to go ahead and start finding my attributes. So the first thing I want to find is my y-intercept. So I'm going to press Gsolve, and then I want y-intercept, which is going to correspond to F4. So that gives us 0, 0. So the next thing is I want to write the end behavior of my graph. Now, of course, this is going to be in limit notation. When I say limit notation, or rather, when I say the end behavior, it should be implied that I'm telling you to write it in terms of limits. So for this one, our graph over here on the left side is going to be going down, and on the right side, your graph is going up. So my limit as x is approaching -infinity of f of x is going to be -infinity, and then my limit as x is approaching +infinity of f of x, that's approaching +infinity. Now we're looking for local extrema. So on my calculator over here, we can just do graph solve, and then we have your max and min. So the first one I'm going to do is a local max. So I'm going to press maximum, and ta-da! So we're going to have 2.277, but then we have e to the -3, and then we have 5.689 e to the -5. So this is the same as writing it times 10 to the -3 and then times 10 to the -5 respectively. So these numbers are going to be so small that they're practically 0. So I'm going to say local min at 0, 0. Whoops, local max, not min. Hello. Okay, and then now I'm ready to do the local minimum. Local min. So F5 and then minimum. And then we're going to round it to 3 decimal places according to AP. So this is going to be 1.144, comma, -4.757. Move over. Thank you. All right. Now we're going to look at absolute extrema. So this is looking at the entire graph once again, but we're looking at the highest of the high points and the lowest of the low points. So because my graph goes down indefinitely and goes up indefinitely, what that tells me is we're not going to have any local, or we're not going to have any absolute extrema. So you could write none. And then for the next part, we're looking for absolute extrema on this closed interval. So what you're going to do on your calculator is you're going to have to adjust your window to this specific interval. So I'm going to go to view window, which is F3, and then change to negative 0.61 all the way to 1.47. If I can type it correctly, that would be amazing. All right, so here is a view of your graph. So I'm looking for the absolute minimum and absolute max. So let's do the maximum first. So I'm going to write it as ABS max for absolute max. So F5 and then F2. So once again, I see those E's, which tells me it's going to be essentially 0. So my absolute max is going to be at 0, 0 on this closed interval. And now when I try to look for the absolute minimum, if I do shift and then min, it gives me a minimum inside the interval. So it's going to exclude those endpoints. But if I look at my graph, I can actually see that my lowest point is going to be actually over here on the far left side where that endpoint happens. And then if you kind of ask yourself, well, how do I find that value? My calculator won't give it to me if I try and toggle over. Well, what we can do is a ycal. So what I mean by that is I'm going to press Gsolve, then F6, and then F1, and I'm going to plug in that interval over here. So negative 0.61, rather the interval value I'm going to plug in. So that's going to give us the negative 5.576. So we're going to have an absolute min at negative 0.61, comma, negative 5.576. There we go. All right, now we're looking for the real zeros and the corresponding multiplicities. So these last two parts, I will say, I'm going to talk about this in a later lesson, so I don't want to put too much emphasis on it right now, but we're no longer dealing with a closed interval. So I'm going to zoom out a little bit so I can get a better picture of my graph. So I'm going to focus on the roots. So my real zeros are going to be my x-intercepts, which are going to be at 0, 0, which is also the y-intercept, and an absolute max on the closed interval. Now I need to find what this x-intercept is. So I'm going to do gsolve and then root. So it's going to give us the 0, 0, and then it's going to give us 0, 0 again. And then over here, it's going to give us 1.714, comma 0. Or you could write them as x equals 0 and x equals 1.714. So I'm going to write them like this so that I can also kind of write in the corresponding multiplicity. So when I talk about multiplicity, we're looking at the behavior and what's happening at those zeros. So if I look at 0 right here on my graph, we're bouncing off the x-axis right here. So anytime you see a bounce, that means we're going to have a multiplicity of 2. And if you look at your root over here at 1.7, we're crossing through that root, which means we just have a multiplicity of 1. So if I look at the next part, we're looking at the maximum number of non-real zeros. So if I look back at my original, well, we have a cubic, which means we can have up to 3 real zeros. So if I look down here, if I look at the multiplicities add up to 3. So I can have a max of 3 reals, and my multiplicity accounts for all 3. So that means I would do the degree minus the number of roots, which also accounts for the multiplicities. So that would be 3 minus 3, which means we would have no imaginary roots. And of course, instead of imaginary, you could also say complex or non-real. All right, so that takes care of the left side. Now we're going to move over to the right side. So now I give you a factored form. So on my calculator, I'm going to press exit, delete this garbage, and then I'm going to type in my new function. So we're going to have x squared parentheses x plus 3 parentheses 4 minus x plus 5. So you're going to copy and paste what you see. You don't have to multiply it out or simplify it or rewrite it or anything like that. Just copy and paste it in your calculator. Then enter, then drop. So of course I'm going to need to zoom out probably so we can get a better view. There we go. It's a pretty good view. So starting off, we're going to look for the y-intercept. So I'm going to do gsolve y-intercept, which is going to be at 0, 5. Now I want to do my end behavior. So of course it needs to be in limit notation. So if I look at my graph, we're going down and down. So that tells me it's a negative even function, which we're going to talk about. So what you need to be careful about is that you're using g of x in your limit notation, not f of x. So my limit as x is approaching negative infinity of g of x is going to be negative infinity. And then my limit as x is approaching positive infinity of g of x will be positive infinity. Okay, so now we're going to look for the local extrema. So if I look at my graph, I'm going to have 2 local maxes and then 1 local min. So gsolve, let's go ahead and do the maxes first. So I'm going to have a local max. All right, so we're going to have negative 2.103, comma, 29.211. All right, and then I'm going to toggle over to find the other one. So this is also a local max, even though in this case it will also qualify as the absolute. So then this will be 2.853, comma, 59.644. Okay, so now let's go ahead and find our local min. So gsolve and then min. Which in this case is also our y-intercept. So remember that e to the negative 8, that's going to tell us that we're going to move the decimal of this value to the left 8 times. So that number is so small that it's essentially 0. Okay, so now we're going to look at the absolute extrema. So because our graph is going down and down on both sides, we're not going to have an absolute minimum, but we are going to have an absolute maximum. We can find the high of the high points. So that high of the high points is going to be this local max that's up here. So we're going to have an absolute max. And that's going to be 2.853, whoops, comma, 59.644. All right, now we're going to do a closed interval. So once again, I'm going to go to v window, and I'm going to adjust my window. So we want the window of negative 0.61 to 1.47. So negative 0.61 to 1.47. So exit and then draw. So I'm going to adjust my x values to make, or the y values rather, to make these a little bit more obvious. So let's do like negative 10 to, I don't know, let's try 20. Actually, no, let's do 30. Yeah, still cutting it kind of close. So let's go ahead and change you to 40. There we go. All right, so I can see the absolute minimum is going to be over here, and I can see my absolute maximum on this interval is going to be on the endpoint on the right side. So let's go ahead and do the absolute max first. We've been doing the maximums first. So in order to find that maximum, like if I try to just do max, your calculator is going to say not found because the highest point is going to be on the interval, but your calculator doesn't know to include that interval. So what I'm going to do is a ycal. So gsolve toggle ycal, and I'm going to type in the endpoint value that they give us, which is 1.47. So 1.47, which is going to give you that absolute max on this interval. Make sure when I write you can see. So my absolute max, which in this case is going to be 1.47, comma, 29.438. All right, so now we need to do our absolute minimum. So gsolve and then min, which in this case is going to be the y-intercept. So the absolute min, which is going to be 0, 5. Okay, so now I'm going to zoom back out because now we're going to look at the roots. Honestly, that's good enough. And let's zoom back in. All right, so when I look at my roots, so we're looking at the zeros. So I'm going to do F5 and then look at the roots. So we're going to have a root at negative 3.075. And then we're going to have another root This is probably how I should have wrote it out the first time, but it's okay. 4.043. So these are the two roots that we have on our graph. So looking at the behavior at these roots, we're crossing in both, which means we're going to have multiplicities of 1 and 1. So then when I'm considering the maximum number of non-real zeros, which is our imaginary roots, we're going to look back at your original polynomial up here. So I can see that we have a degree of 2, 1, and 1. So that means our degree here would be 4. So we have a degree of 4. But then we only have 2 real roots, including the multiplicity, accounted for. So I have a degree of 4 with only 2 of the roots accounted for, which means when you subtract, we're going to have 2 imaginary or complex roots. Ta-da! Make good choices.